Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to take a look at a second-hand power supply which I purchased off eBay for £15, and hopefully we're going to get it working and refurbished, and so I can make use of it here in the lab. What's interesting about this power supply is that it was made in Yorkshire. I'm guessing probably in the very early 70s, although I've not had much luck finding a circuit diagram for the particular model that I possess. And it's made by a company called Farnell, which is a name that you may be familiar with. So I had a quick a search around the internet and have discovered a fairly long history involving Farnell. It was founded in 1939 in Leeds, and it was based next to Wetherby railway station, although later it moved to the Starbeck area. And there's had various companies that it's acquired as the years have gone on. In 1995 it acquired Premier Industrial Corporation, an American company, and changed its name to Premier Farnell. In 2016 it was acquired by Avnet, which again is another American company, and they rebranded it back to Farnell again. So it appears the name has gone full circle. However, it's nice to actually have something to work on that was made probably about 40 or 50 kilometres south of where I am now, in the what was probably the West Riding of Yorkshire. So let's start by taking a look at this instrument and what it is. Okay, so this is the unit then, yet to be powered on, but as you can see, cosmetically, top of the case has a slightly hard life. Front panels, apart from being a little bit grubby, is in reasonable condition. The front of that knob is missing, but appears to turn okay. And in terms of settings, we've got power on off, and then here we've got the switch that switches between the 15 volt 1 amp range and the 30 volt 0.5 amp range, and then that's this button here switches between volts and amps on the meter. So relatively straightforward, and obviously we've got plus minus and a ground connection. So it's come with a mains plug, and the mains plug, your standard UK mains plug. I haven't switched it on yet. I want to just have a look inside and check that there's nothing awry before I apply mains voltage to it. As I mentioned in the introduction, it has the eBay description said it had been switched on, but no other tests performed. So I'm going to just have a quick look inside before I do anything like that. So it looks like there's screws to remove here and here, so I'll get that done and then we'll have a look at the inside. Okay, so 4 screws came out and nothing happened, so I discovered I also had to remove the 2 screws out of the top handle, which were attached to those part of the case. So it's quite nicely made in the sense that this bit of the case is one piece, and it looks like those 2 screws will allow me to remove the front panel. There appears to be a socket there and also a socket here, so you can relatively easily get at the circuit board. So relatively conventional then by the look of it. We've got this transformer here which has got taps for 220 and 240 volts. We'll leave it on the 240 volts in here, and there's 2 primaries, a 21021 and a 28028 there, both which appear to be in use. We've got fairly large smoothing capacitor down there and a few other electrolytics about, so we're going to need to check those. This is probably early 70s, I would imagine, so I guess some of these capacitors may be past their bests. So things that I've noticed straight away is the earth lead here, which is very thin. Has had the some of the insulation has melted off it. I don't know how well you can see that, to be honest, probably not very well, but it has. And it's this is the incoming mains lead, that's the neutral, that's the live there, that brown, this is the earth, and it's a very thin mains lead, considering there's a a mains 5 amp fuse there. I'm not entirely convinced that I want to feed 5 amps through that, so no matter what happens here, I'm going to be replacing that with something a little bit more substantial, and clearly we need to sort out the earth so that it's not bare wire there. The rest of it doesn't look too bad, with the exception, and again, I don't know whether you can see this, probably not incredibly well, but there is a Zener Diode here. It's Z1, and there's some appreciable darkening around that diode, which suggests it's got rather hot in the past, and it's also visible under the case there as well, so that's that looks like that might be a potential failure point. Probably wouldn't stop the power light coming on and off, but it may well have stopped the unit working, but we'll see in a moment. So next thing I'm going to do is I'm going to get a multimeter and just check that we haven't got short on the transformer, which obviously matters. So we'll go to ohms here, and I'm just going to, that says SCR in there, so I'm guessing as it's got green cables attached to it, it's going to be the screen on the transformer, and I'm getting 0 ohms there, so that's probably good. So we've got 0 here, and that's 240, so I'm just going to see what we get. I'm getting about 110 ohms there, so that suggests the primary is in good condition. So I think next step is to risk powering it up. So I'll just get set up for that, and then we'll see what happens. Okay, I've got the meter set on volts attached to the plus and the minus. I'm going to turn the course down, so pushing in will give 30 volts, leaving it out should give 15 volts. Switch the power on now, so I've got mains power into the cable, and so far so good. So we'll try switching the power on and see what happens. Okay, we've got a light. Nothing's happened there, but that is turned right down, so I would expect that. It doesn't appear to be anything emitting smoke in the back, so that's probably also a good start. It could of course be completely dead. All that tells us really is that the main switch works. So let's try turning, well, that's a good sign. So turn that to 5 volts, and according to the meter we've got 5.17 volts. That's a very good start. Clearly that Zener diode can't be completely dead, well certainly not on the low range anyway. Let's go up to 10 volts roughly, see what we get there. That's about 10 volts. Yep, 10.1, and that should do 15. There's a fine control there, so I'll turn that. That's about, yeah, bang on 15 volts, so that's good. I'll just back that off, and I'm going to push the range switch in, see if that makes any difference. So we should get 15 volts again there, which indeed we do. Does it go above it? Yes it does. 20, 25, and that's 28.8. Let's wind her up to 30. Yep, 30.1 according to the meter. So that's a very good start. Now it's not drawing any current, so I would expect pressing that to give me pretty much 0, because that's obviously measuring the output current, but clearly the output on volts appears to be working fine, so that's extremely encouraging. Good. Okay, right, I'm going to turn that off, and I want to investigate a little bit more now and have a look at see if I can determine what's going on with the blackening around that Zener diode. So I'll just get disconnected, and then we'll have a look at that. Okay, remove those 2 screws at the bottom. I've unplugged this multi-pin plug here, and then that circuit board is withdrawn from that socket there, which is rather handy for working on things. So now we can see a little bit more clearly. I don't know how well you can see. Yeah, you can actually see that, can't you? There's the darkening on the circuit board around that Zener, and certainly on the top there. Now it would still appear to be functional, so we're going to do a few tests on that. But I've also noticed this multi-pin socket, which incidentally brings the mains voltage in on those two end pins, that pin there is actually also darkened, so I'm just wondering if at some point there's been drawing a lot of power and that's somehow shorted down to earth, and as that's what's perhaps done the melting of this insulation on this earth lead where the mains comes in. I don't know, I'm guessing obviously it's probably had a long hard life. So I'm going to get set up to do a bit of checking, and then we'll have a look at what these components are doing. Okay, so I want to check first of all to see if this Zener diode really still is a Zener diode. I suspect it is, because the power supply does work, but I'm obviously a little concerned that that's probably past its best. So the way I'm going to check that is I'm going to use my curve tracer. So here is display there, that's the display from the scope, and if you're familiar with a curve tracer this will make complete sense. But if I connect the probes together we get the vertical line. If I get a electrolytic capacitor here and put that in, we get the characteristic elliptical shape there. This is a Zener diode, and with the Zener diode we get that very distinctive shape. We would get one of those knees, the one that goes down, you'd expect with any diode, since that's the forward bias voltage, but the other knee is the Zener's voltage. In this case I think it's a 4.7 volt Zener, and the distance that right hand knee is away from the center gives you an indication of the Zener voltage. So what I'm going to do is just try testing it in circuit, and I've had a quick look at the traces. I've been struggling to get a circuit diagram for this. I think it's in parallel with some capacitors, so I don't know what kind of result I'm going to get, so let's try that. There we go. Well, it's got an ellipse, so there's clearly some capacitance there, but it also appears to have a sort of a knee of some sort, so there clearly is some kind of diode activity going on. I'm just going to try one of these diodes down here, and that most definitely is what you'd expect to see from a diode, as is that one. This is a resistor. I'd expect a sloping line from a resistor. I suspect that's in parallel with a diode somewhere, because we've got that little blip at the end. Again, another resistor there. Yeah. So okay, what's that capacitor doing? Yeah, that's clearly got some diodes on the go with it, and we'll try that electrolytic. Yeah. Okay, well that's actually quite a positive sign. The problem here, of course, is it's still in circuit. So what I'm going to do is I'm going to have to unsolder one end of that so that I can have a proper check of it. So I will warm up the soldering iron and do that. The other thing I'm not quite able to see is the numbering on the diode. So it needs to come out anyway, really, for me to be able to do that. So I'll get the soldering iron warmed up, and then we'll see what we get when she's out of circuit. Okay, this solder is getting on a bit. Those are the two connections, so I'm actually going to put a bit of new solder on before I do any kind of solder removing, just to hopefully get rid of any oxide layers over the of the original soldering, which I'm guessing is going to be probably 50 years old now. So with that done, next thing we can do is start using some desoldering braid just to remove the excess solder. So I'll do that and then show you how I'm getting on. Okay, probably too small to see, but I've now removed the excess solder, and the ends of the diode have been leads have been bent over before soldering. So next thing I need to do is try and just straighten them up so that they will hopefully pull out of the hole. That's one side done. I think I need to do a little bit more solder removal on this side before we can. Is it going to go? No, maybe not quite. So a little bit more desoldering required on that side, just to encourage that wire to bend up. It's quite a large pad, so requires quite a bit of heat. I'm trying to be as economical as possible with the heat, as I'm dealing with a semiconductor device, but I need to get rid of the solder somehow, so I'm going to find a compromise. Yeah, that's looking better actually. Yeah, I think that might prise up now with a little bit of encouragement from a small screwdriver. If I can just get that in there. Oh yeah, there we go, that's it. Right, so that's both ends of the Zener now straightened, so it should pull out of the hole. So I'm going to apply absolute minimum force with the screwdriver there and just encourage the solder to melt in the hope that I can. There we go, that's a good start. I think we probably just need a bit of encouragement with pliers, which will also act as a bit of a heat sink and hopefully draw some of the heat away from the component. Right, that's one end undone, and the other end actually feels loose, to be quite honest. That might just come out with the pliers now. Apologies, it's not the easiest thing to record on film. Let's put the soldering iron out of the way so we can see what's going on. So I've freed that end. This end doesn't really feel as though it's connected, so I think there we go, that's the Zener diode out. So let's get the curve tracer fired up and let's see what kind of thing that's telling me. So remember, we should expect 2 knees if she's still a Zener diode. Only 1 knee there. That's not ideal. It's definitely a diode. Whether it's a Zener diode or not is another matter. Certainly my curve tracer doesn't appear to think it is. I do, however, have another way of checking, and that's the trusty component tester, if it's got any life in the battery. Yeah, it has. So we'll connect the component tester up like so, and we'll just press the test button and see what we get. Well, we'll do if it'll just start up for me. There we go. What's that reckon it is? It reckons it's a diode with forward voltage of 713 millivolts, so it certainly doesn't think it's a Zener. So I'll get the magnifying glass and have a look what number it is, and get one of those or an equivalent ordered. But I'll obviously, in the meantime, I'm going to put the original back in for now while it's still working. Okay, so I've refitted that Zener. Had a look at the data sheet, and I do believe it is a Zener diode, but I think the voltage is too high for the Zener diode voltage is too high for my checkers to actually indicate, and that's probably why it's just showing up as a conventional diode. Plenty of people appear to have them in stock, so I'm going to get one of those ordered up and get it replaced anyway. There's no harm in that. And I've checked these capacitors here, and actually they're giving me quite sensible results, and they've also got reasonable ESRs, same for that one as well. And the large electrolytic under here is also giving me a sensible ESR measurement. It's despite the fact it's a fairly chunky and quite high value, it's nonetheless testing out okay, which is good. So next thing I'm going to do is I'm going to clean up that darkened pin to improve the contact. I definitely need to spray these switches with a bit of contact cleaner while I've got the whole thing undone. And I'm now going to go ahead and replace this rather thin mains lead with something a little bit more substantial, certainly capable of handling 5 amps easily enough, and then we'll have a look up and see about putting it back together. Okay, so here's the unit back together. That's the diode I removed. I've replaced it, and but I've left the leads straight, so it's relatively easy to change it when I get the new component ordered. Given all the switches and the pots a good dose of switch cleaner and worked them well. And the bit that I think was probably the worst was the mains lead, and that was the, probably can't see it terribly well, that was the earth wire which had the insulation melted off it. So I've replaced that with some actually some 10 amp cable and proper soldered earth connection, so that cable will last far longer than the 5 amp fuse in there, but more importantly the 3 amp fuse that I've put into the mains plug. So I'm going to just check that the voltages are okay. I'm going to give it a little bit of a clean with a bit of isopropyl alcohol just to tidy it up, and then what we'll do is get it under load and just see how clean the power supply looks on the scope. Okay, so I've got the output of the supply hooked up to a wire wound resistor here. I've got the scope across the output so I can look at the noise, and the meter here is reading current in milliamps, so currently right down the bottom, so I think I've just about 3 or 4 milliamps, something like that. So I'm going to just increase until I get something about 250, if I can get that accurate with it. Probably use the fine control I can. So that's saying 250 milliamps. Small amount of noise, not too bad, but the bit I really want to check is this current meter. So pressing that button puts me into current, and it indeed is telling me it's 250 milliamps. So I'm going to just increase voltage now till I get to 500 milliamps on the meter here, and 0.510. I'm not in line with the needle, so that's what that's telling me is that the current measurement function on here is actually very accurate, and again almost no change at all in that. That's currently set to 500 millivolts per division. So I'm going to back it off again then, and just need to remind myself that on the high voltage scale it's a maximum of half an amp, so we'll just gently increase that to about 50% of it. So that's, well, there's 100 milliamps. That is indeed saying about 100 milliamps. So I'm just going to go up to about 300 milliamps. Yeah, exactly, very good. And that's just over 5 volts. So with that particular resistor I don't want to go any higher than that because I'm approaching the limits. But current meter reads nicely. Voltage we've already ascertained is correct. The noise difference between the two ranges is negligible. So I think that's the result. So I just need to get the Zener Diode ordered and fitted, so I'll get that done. But that's £15 well spent, and as Tony Albus says, you can't have too many power supplies, so good job. Okay, well that's about it for the refurbishment of the Farnell power supply. Hopefully it's going to give some good service. I've looked up the number of the Zener Diode and managed to find a fairly ancient spec sheet, and it is apparently an 18 volt Zener, and they're certainly still available, so I've ordered some, so when the replacement arrives I'll get that fitted, but that's a fairly straightforward job, and it's quite handy having 30 volts available, and I'm certainly not going to need more than half an amp for the things that I get up to. So that was £15 well spent. Hope you've enjoyed watching it, and if you have, please click the thumbs up. If not, you can click the thumbs down. Either way, be great if you could consider subscribing, that would help me, and we'll look forward to seeing you on the next video.